Right. Good afternoon, everyone. Welcome to Wednesday afternoon's lecture. So today we're going to be discussing files, and we're just going to discuss the theory surrounding files. We're not going to go into the actual usage of files yet. We'll start doing that as of tomorrow morning. So tomorrow morning, you definitely should not miss out because there's only about 4 weeks left. If you include this week, there's 5 weeks left. What file types are we using? We're just going to use text files at this point, but ultimately a file is a file. You can read in any file as long as you know what the format of the storage is. So we'll get to that later on in the semester. So what we're going to do today is we're going to discuss the theory surrounding files, and we're going to discuss some of the things you might need to know. So a lot of you might know this already, so it's going to be a slight rehash, and a few of you might learn something new today. So the purpose and the outcome is to learn about the theory behind files. Why do we want to use files? Why are they there? So data and machines. So some small background. Until now, variables and arrays are internal structures. That's what we've been using. Now, keep in mind that variables and arrays are only used as temporary storage. So when your program terminates, you lose that information. So we use files, or your introduction into some files, to be your persistent data, to make sure that we don't lose that information into external data structures. So a variable goes out of scope once a program terminates. So as soon as the program closes, that information is gone, which is not a very good thing if you want to store and keep track of something. If you just want to calculate something quickly and you're going to give it the values, then temporary storage is perfect. But if you want to keep track of things long term, then you want to start considering external data sources like files, databases, and those are actually your two main external storage systems. So you've got long-term retention of data, your persistent data, and data maintained in files. So when we look at the data hierarchy, the similar data is often grouped together. Let's consider the following pieces of information called fields about a particular student. So you've got a student number, you've got a name, no, that's a surname, initials, and then you have a additional, let's call it a grouping. So each one of these are considered a field, an individual piece of information. If you group them together, you form a record. Now, a record is a collection of fields that provides you with information. So you've got the student number for this specific student, the initials for this specific student, and the grouping for this specific student. Now I'm referring back to this specific student because it's just, yeah, it's something people are used to. You've got Trump, Obama, Bush, and Clinton. It was on the top of my head. I've been following the YouTube news recently of the US politics. Right. So you've got a field. A field is an individual piece of information. A record is a collection of information, related information, so they relate to one another in some form or another. Then if we group a collection of records together, in the previous semester we worked only in primary memory by storing this in an array. So we're going to group things together and we're going to group it into a file. So we're going to output that into a file, but currently in our program we store it in an array. So if you want to keep track of multiple objects, I'm going to call them objects for now. If you want to keep track of multiple objects or multiple records, then we put that in an array and store the information individually inside each one of them. So I'm hoping all of you are still comfortable with that. Because you have your classes. Your class represents an object. Once instantiated, you set various items inside this object. And then if you want to keep a collection of this object, you create an array. And that is all currently temporary storage inside our programs. Alternatively, you can save these records into a file. So instead of storing it temporarily in our program, we can store it in a file and use it from the file as well. Now keep in mind, the process of storing information can only go as fast as the device you're storing it to. So if you're just storing it to a hard drive or storing it to a USB, it will only be as fast as that specific device's storage and how much access the machine or the computer gives you to that specific storage. So there are some limitations to where and when and how you can store things. Also something to be kept in mind. So this ensures that data is still around even after we close the program, since it is saved to a secondary storage, which can be onto the hard drive, the USB, or any secondary form of storage. You can store it to a CD, you store it to a floppy disk, if you guys even know what a floppy disk is. But what it boils down to is how you store information. So, machine language. I'm assuming you guys have seen machine language before. Maybe not written it yourself, but we'll definitely have a look into that. I think we have enough time to teach you how to read that. I believe you do this in computer science as well, where they teach you how to read binary code. So machines only understand ones and zeros. Ones and zeros, yes, matrices. Yes, I'll print you a few if you want. I actually have a few boxes of still wrapped up floppy disks in my cupboard. I still have an interesting project for them. All right, so machines only understands ones and zeros. So whatever you do, ultimately it gets converted into a 1 and a 0. So each of these ones and zeros are collected and called bits, binary digits. And it's either a 1 or a 0. That is your bit. Computers reduce data into a combination of ones and zeros for processing. How then do we convert the data in each field of a record into these ones and zeros? So there's a few things you can do. I'm assuming those that did computer science, you were taught hexadecimal values, you were taught binary. What is the other one that they normally teach you as well? I think there's about 3 or 4 that they normally teach you, but binary and hexadecimals are definitely there. Octodecimals, I think that's a new one. No, it's not. But it's definitely interesting to see how things convert. So you can either have a 1 and a 0. We take a subset of this 1 and 0 and determine a value based on that. Or you have the hexadecimals, which go from a 1 to a 9, A to an F, if my memory serves me now. That can also represent a value and helps you store information into a way that the machine can understand this. So each character can then be represented as a combination of ones and zeros. But this also depends on the encoding. So we may use different methods called encoding to represent our characters, and there are 2 main encoding methods that a computer uses. So you've got the ASCII values, so ASCII, so you've got ASCII and you've got Unicode. Now before I continue, which one is the better one? I want to see how much you guys know about this. Which one of the 2 is the better one to use if you're talking about the encoding methods? All right, some of you are saying ASCII. Any takers for Unicode? I actually want to do this. Let's have some fun with this. Let's do a poll. Which one is better? Let's see. Maybe some of you are just too afraid to give your answer. So we have ASCII and we have Unicode. Let's see what you guys think. So you should see a pop-up on your screen, and I want to know which one is better. I'm already seeing a lot of people saying ASCII. I might surprise you in a second. I see it's now fluctuating. Unicode is catching up. Come on. I want everybody to vote. I'm going to give you the correct answer afterwards. Unicode. Don't give away the reason yet. Those who are like me, who don't know, it will say ASCII because majority said ASCII. That is a fair point. Just because you said you're going to be surprised. There is a correct answer, yes. All right. So the majority of you are saying ASCII because you're probably used to ASCII. If you look at text-based art, they generally use ASCII values as well. But in my personal opinion, Unicode is better. And I'll tell you why. It's how the characters are represented. And that's what it breaks down to. So when you go to ASCII, ASCII is represented by 1 byte, 8 bits. So it's represented by 8 individual bytes, a 1 and a 0. So you've got either 8 ones or 8 zeros or a combination of ones and zeros, but for 8 characters. Unicode is represented by 2 bytes, 16 bits. So each character is represented by 16 individual ones and zeros. Now, me telling you that, what does that mean? That's an interesting question. We'll get to that in a second. No, not more data and less space. Yes, Unicode range is bigger. It can accommodate more information. So Unicode, where ASCII is represented with a standard, so if I can show you, let's just see if this, yeah. So if we go ASCII, and an ASCII table, and let's open up a Unicode table as well. ASCII has a limited representation. So you've got there's your decimal value. So that's your generic number representation, which goes all the way up to 255. So you have 255 potential characters that you can represent, and that's that. That is your limitation. It also gives you your hexadecimal, your octadecimal, and then your char representation, and then what it actually represents on the side. So you've got different representations. So you've got your A to your Z, and you've got your uppercase and your lowercase versions of those characters. But as you can see, there's a size limitation, 255 character representations. I say char, it's generally considered to be an individual character, this, because it's one representation. ASCII represents an individual thing. Now, for instance, over here where it says space, that represents a space, like a tap on the space bar, that type of a space. So you've got different character meanings. Some of these characters have meaning more than it has anything else. Now, if you go to Unicode, let's go for a Unicode overview. Hoping it will show us a Unicode table. Now, let's just search for a Unicode table. Open up the first link, hope it's the correct one. All right, so Unicode table has, like I said, 8 8-bit representation. So currently you can see that it has a lot of characters that it can represent, which means it can represent other languages as well, because it can contain those characters. And that's why, in my opinion, it is better, because it can contain other languages. As you can see, I'm still scrolling down this list. So there's definitely more than 255 representations. See, where's the end of this? We're still scrolling, So you can see it can handle a lot of information. Let's see how many. Unicode. Shark count. So it can represent up to 143,859 characters. And some of these are graphic in nature, but ultimately it's a character representation. Right. So that's why I say Unicode is better, but the majority of a lot of programs are swapping over to Unicode. They give you the option between Unicode and ASCII, but a majority of new programs are swapping over to Unicode because it supports multiple languages. You can easily swap one language for another language. Well, I say easily in quotation marks, I should probably add. So it's still up to you. If you still use a English-based website, then ASCII is more than enough. But the moment you go over to other languages where you need special characters, then you need to start considering Unicode, because not all of those special characters are used in ASCII. So some terms that you need to be aware of, things that we discussed, is a bit. A binary digit can only be a 1 or a 0. So something to keep note of, you've got a byte, which is 8 bits. You've got a nib, which is half a byte. You've got a field, a group of characters that convey a meaning. So this is now the data type itself. Ask no questions, tell no lies. You forget sometimes, okay? People become forgetful. You're not going to work in binary. So most of you, after being taught binary or hexadecimal for a while, will have some fun with it. And then after that, it's one of those things that you know, but it just goes to the back of your mind. It just stays there. Because when you work with this, you're not going to actually work with ones and zeros. You're going to be converting it through the use of a function inside the IDEs. You're not going to convert it yourself. So it's a fun project for those that actually want to do a nice holiday project. Once they're done with their group project, is they can create their own converter. Just fun of it. Then you've got a field group of characters that convey a meaning. So this is now like a string, an integer. You've got an individual representation that has a meaning. Then you've got a record, which is a group of several related fields. So if you think of an object, a class, a single record will represent an object because it will be every single characteristic of this object. The name, if you think of a person, it will be your name, your ID, your surname, your age, any information that needs to be stored. A file is a group of related records. So a file will store a group of related records, and that is what we'll be doing as of tomorrow. And then you've got a record key, which identifies record to a particular entity. Now, remember when I spoke about it reads to the specific student? So you will have an identifier in this record, something that will identify the record, or which will allow you to identify the record. And you'll learn a bit more about that in your second or in Informatics 2A about how information is specifically identified. But a record key identifies records to a particular entity, a student number, an ID, a username, something that is generally considered to be unique to that specific record. to be kept in mind. You can count from 1 to 32 in binary with 2 hands. It's still going to take you a while, though. If you really think about it, you can have 255 representations with your 2 hands, because with 8 fingers, you've got the entire ASCII table on your hands. Something to think about. All right. So that's basically it. Today is all about just giving you the basic terminology for files. So I want to find out from you guys, are there any questions you have? Is there anything about the terminology that confuses you, that you just want me to recover quickly? Because the moment we start with sequential and random access files, I'm going to start using this terminology every single lecture. So you need to be comfortable with what they are and what they represent. Field, group, and file. All right. So this slide makes it a bit easier. So if we talk about a field, so similar data is often grouped together. Let's consider the following pieces of information called fields about a particular student. Now, the easiest way I can explain this to you is consider a data type. Now, if we look at student, what data type do you think student's going to be? Okay, some of you are saying integer. I won't fault you for that now, but technically it's going to be a string. And there's a reason for that, but that reason I'm only going to teach you in your second year. Then we've got a surname, and that I'm pretty sure we're all comfortable will be a string. We've got initials, which will be a string, and then we've got beta, which will also be a string. So we've got 4 individual fields, and each field is a string. Now, if we talk about a similar data is often grouped together, we're talking about the data itself. So if you go to this, you'll see that a student number becomes a field. So this first grid or this first column represents the student number, and that is considered to be a field. Everything under that column would be a field. So in this example, you would have 4 fields, which is 4 individual variables that represent a single record. So a field is that individual variable inside a record, and a record is the collection of variables that represent that specific line, that specific record or specific object that you're looking at. Now, you'll probably get more used to it once we do it practically, because you're used to the fact that we have a class, and a class has the characteristics inside. So you'll have a name, a surname, an age, let's say a date of birth, and every single one of those instance variables inside a class is considered a field. The object itself, the class, each instance, that class is a record. And a collection of those records, if stored, becomes a file. So your array of classes is the information you're going to be storing to a file, so that's your file. Your record is a single item inside the array of a class, and your field is every instance variable inside your class. If that makes it easier to understand how to break it down for yourself. All right, so let's consider a class list. Let's say I want to keep track of the attendance of who attends these sessions. So when the session starts, I would enter in the student number, the surname, the initials of the students. So I've got student number, surname, and name. Once the session ends, I will close the program, and it will take what I have inputted into the program and store that to a file with today's data added to that. So when I load up the file again, it can load up all that information for me, and then I can go and track. I can ask the program, how many classes has this student attended? So I can read in the file, go and count how many times that student has attended a class, and then output value. One solution, or one potential solution that's easily enough for us to implement inside 1A. Now, there is a lot of implementations that you can consider. Consider the fact that when we capture your marks, I can do that in program, capture your marks, store it to a file, and keep it for record's sake. Or when I need to go and change it or read it back in, instead of having to enter every single mark again, I could just read it from the file, have it on record already. So for instance, when we calculate your semester mark, instead of having to go and input every single student's mark individually, I can just go and take the files that have been created and then take the marks that have already been entered and stored and just combine them together, instead of having to type out 10 to 20 marks per student for 300 students. If that makes sense to you. Yes, you can field as a variable. A field is just that individual representation of information. It can be a variable, can be an instance variable. I like referencing it as an instance variable, because when you store information, a field itself is related information. So when we're referring to a field, if we say student number, it's all the student numbers. So it's not something that gets confused easily with other things. If we open up, here's my mouse. If we open up Excel, open up a blank sheet. So if you think in terms of your grid, let's look at something like student number. If you think in terms of how we would calculate marks, we go prac 1, prac 2, prac 3, semester test 1, semester test 2, exam, and then you'll probably have a semester mark and a PCM. Right. Now, if we create a class to represent this, you'll most likely see, let's create a new class here. You'll most likely see that you'll have a class called student, or student marks, student mark. And then you'll have a student number. You'll have practical, so you'll have pract as an array. Call this an int. You'll have student number. It's a string. You'll have your semester test 1 as int. You'll have semester test 2 as an int. You will most likely have a semester mark and a PCM and an exam mark as int, as int, as int. What you have is that represents a student mark. So one line here, let's go and add a student. So we add a student, we have 50% for the prac, 50% for the second prac, 50% for the second prac, 100% for semester test 1, 100% for semester test 2, and then those three will be empty for now. So if you consider the fact that you have a student mark, which is identified by the student number. So that is what we're referring to as the record key that identifies that particular entity's information. So that student number identifies the student's marks. But then you've got prac1, which is a field. So you've got the prac1 field, the prac2 field, the prac3 field, semester test 1, semester test 2 field. So that represents your practical 1. So the moment I add more students, to the system, you have the fields. So field 1 is the practical 1. You've got the records, which represents the entire student's information. So that specific student's information, but you've got a collection of records and everything stored will be my file. Now, why we want to use files is consider the fact that when we go and calculate the semester mark, do you think I want to go and type in all of this information for 308 students the moment we calculate the marks? And I mean, if you really consider it, it's 3 times this information. No, I don't want to go and calculate it. I don't want to go and input that value every single time, because the potential for a mistake becomes very likely. So this information is stored week by week. When prac1 is marked, we store that mark. When prac2 is marked, we store that mark. When prac3 is marked, we store that mark. Same for semester test 1 and semester test 2. When it is marked, the mark is stored. But when it is time to calculate the semester mark, all I have to do is I just have to go and load up the information from a file, and then I can do my calculations. So the input comes from my file, because that's where my information is stored, and then I can just do my calculations and output my calculations to a file. And that is most of the times how we do it. I mean, when we do your semester marks, we literally store it to a file. Unfortunately, I can't show you the actual way it's being stored. Let me just see if I hide the information. Okay, so I can do that. So what will happen is we'll store your informations in a file like this. So we store that information per student, we capture it, and then this is what we upload to Eve. So that information is kept, and the moment we calculate your semester marks, we just simply have our program pull all the information for us. Yes, you can create a program like that and sell it to a school. It's fairly easy. But you will most likely ultimately not use a file. So we're starting off with a file. In your second years, you'll use a JSON. That's what you'll most likely use in a scenario like this. Because that is what we're using. We're using a database, but just to capture the information, we use an Excel spreadsheet right now. So it depends on what you want to use and what the purpose of that application is, what you will use. But we're going to first teach you how to do a file. And you can do files to even create an Excel spreadsheet. Because ultimately, all you're doing is when you save this information, you've got various types of ways to store it. But all of this still represents the same information. It's just how the information is stored. Because I can store all of this to a text file, which I won't be able to show you because then it will show the student names and student numbers. So it's very easy. But it's how to store it. How do you separate them from one another? And when you read it into the program, how do you identify them? Because if you think about it, that is a field. Question 1, question 2, question 3, question 4, and your total. Those are fields. Then you've got your student. So that's a Well, you did good, so that I don't have to worry too much about that. But that is a record. This entire line represents a record, which represents one student. And all of that information combined identifies that. Just to give you an example. Sorry, I'm just blacking out this because it's, the POPI Act. I can't really disclose privately identifiable information. All right. So does that answer your question about covering fields and records again? Does it make a bit more sense to you now? Okay, perfect. It's very important to understand the differences between a field and a record. A file, not as much now, but just a field and a record, because we'll be using them independently. And you'll see from tomorrow's lecture, once we start with sequential files, it's when you use classes, it becomes a bit clearer to you what we use them for, how we identify them. So I wouldn't be too concerned if I was you. The information being provided will be fairly substantial in terms of how to identify what and when and where you want to store it. All right. So that is it for today. That's basically just terminology that we want to teach you, because that will become important for our file discussions, which will start tomorrow. And I believe Prac 10, I think it's Prac 10. Prac 10 is a sequential file. So you must be able to do sequential files in order to do Prac 10. We only have 2 more topics. We only have, well, technically 3 more topics, so we still have social aspects. But files is sequential files, random access files, and then social aspects, and then we're done. Keep in mind, there's only 4 weeks, excluding this week. There's only 4 weeks left, and then it's the end of your semester. So there's not a lot of time left. There's really not a lot of time left. So on that note, just a few announcements. Anyone that has not written the main paper or the SSA, please note that you will have to apply to write the special SSA. That will be the Monday after the recess, which is next week. The Monday of recess, the notice will be on Eve as well. We will have a boot camp. So for the students that are struggling or that missed something and are trying to catch up, definitely attend the Monday tutorial or the boot camp. It will be, I think it's 2 3-hour sessions or 2 2-hour sessions on the Monday. It's just so that you can cover or basically catch up with the work we've done since the beginning of the semester. The Prac 9 is a partial past paper. I don't think we gave you the full past paper. Let's just have a look-see. I think it's been released, or it will be released this week. Yeah, it's one of the past papers that we're giving to you. And it is a full past paper, I think. Yeah, it's a full past paper. That is Prac 10. Why? Oh, is it not a full past paper? Is G missing? No, there is no G here. See, what's the total here? 100. Okay, but this is Prac 10. This is the one you're getting on Friday. It's not the one due on Friday. So this is the one you're getting this Friday. Prac 9 is the one that's due this Friday. This one does not have a G. Yeah, so no G. Yes, it's due on Friday, I think. Of course you're getting a practical on Friday, but it's only due the week after you return. So you've got 2 weeks for that. So you can take your holiday and then still have a week left to do it. In fact, I think we even... Oh, no, but we extended the group project. So the group project is due on a Monday, I think. Mr. Gottrell can correct me if I'm mistaken. But I think we said it's going to be due on a Monday. Because that Friday you're writing a ComSci test, so we won't have a practical due that Friday for you. But you can spend the recess working on your group project, and then you can have a look at the Prac 10. But Prac 10 you'll probably better understand after our first tutorial in the 10th week or 9th week. Yes, once we've covered everything, we'll start revision. Now, I have to add that I don't think, let me just say, check our schedule. I don't think we have revision worked into our schedule. Let's just double check. Again. What do you mean so many pracs left? There's only 2 pracs left, excluding the one on Friday. Due on Friday, which you should be done with already. Let's just see. Yeah, so we don't have any revision worked in. There will probably be a week before you write. So we'll see. But like you can see, there's only 4 weeks left. So we're currently here. Files, tomorrow we're doing sequential files, then Prac 9 is due. Prac 10 is released. Prac 10 is due on the 2nd of October, I think. 2nd of October. Your group practical will be due on the 12th. And then if you're the semester test that week, 1 more week and then we're done. If there's enough time left in the TUTs, so this last week in the TUTs, we'll probably do revision. Yeah, the semester is flying. So we'll do revision in the TUTs most likely, because after we do random access files, you don't have any more practicals due. So as of the 12th week, we'll probably start doing revision the TUTs there, and then do our general lectures. So the lectures covered after anything covered after week 11 won't be tested in the semester test, and it will be theory based because there's no practical on it, and because your exam is theory, it's just theory. So anything after week 12, it's all theory based. There's no practicals on that. So we'll do during the TUTs, we'll do revision so that we can prepare you for the exam. But the exam is theory. It's just study work. It's like semester test 1. Not going to be as easy as semester test 1 though, but it's just study work. All right. Right, ladies and gentlemen, I'll still stick around for the question. If you have any more questions, you can post them in Discord if you're watching the recording. If you're unsure about anything, please make sure you check the TUT tomorrow. We'll probably be discussing... No, tomorrow's TUT will be for Friday's practical. If files confuse you, after we discuss the sequential files, I recommend you come to the first TUT in week 10 so that you can make sure you are on board with files. Now, I have to add, files, there's only 1 prac on files, so you don't have to worry too much about it. But files is something you'll be using for the rest of your academic career. You'll be using it in your second year, you'll be using it in your third year. So I recommend that you get comfortable with the terminology and that you get comfortable with the concept of files. You don't have to execute it perfectly now, but you need to understand files at least. Otherwise, you might struggle in the beginning of your second year. All right, so I'm going to stop the recording here. I'll still stick around for questions for those that do have questions. I see there are a few about the prac, but tomorrow's TUT will also be about the practical. So if you're still struggling with the prac, please come to the TUT and we'll discuss that as well. All right. Enjoy the rest of the evening, day, morning, whenever you're looking or watching this recording.